Okay, so just another little video here on geometry. So in your exam papers, it's page 318, or if you want, you can find it under 2022 Deferred Paper 2, question 6b. So in the diagram below, the point D is on the line segment AB, and CD is perpendicular to AB. So even the mention there that it's perpendicular explains our right angle down here. So the angle ACB is a right angle. So we're told this is a right angle here. The diagram is not to scale. That means you can't measure it with a protractor or anything like that, set square. From the diagram above, write down another angle that is equal in size to the angle DCB and another angle that is equal in size to ACD. So there's a suggestion here that we need to break up this diagram into its separate pieces, really. So I'm just going to draw the overall one first. So for example, ACB, that's 90. Now, if I do a little dot there and a little arc here, we can then kind of piece that together with some of the other diagrams. Okay, so that's the overall big one. Now let's do one of the smaller ones. So let's say we do ACD. Now we know that that is 90. It shares that angle there, so I'm going to use that, and then the remaining one would have to be the dot. And then if I draw the other triangle CBD, that's 90. This one shares the dot, so that would suggest that that one is the arc. So I suppose the tip here is to, if any mention of similar triangles really is drawing out the separate triangles. So we want an angle equal in size to DCB. So DCB, if we look at the original triangle, DCB is that one. So in our broken up diagrams, it's this one here. So we're basically looking for an angle that's the same as the blue one. So an angle that would be the same would be, well, this other one, because they both have those arcs. So DCB is the same as D, the measure of the angle DAC. You could also say CAB, as long as it's there, the angle at A. We want one now that's equal in size to ACD. So ACD, let's mark that in pink. ACD in the original diagram is there, or in this one is here. So that would be the same as this one over here. So we're going to call that the measure of the angle CBD. Okay, it says the ratio of AD to DB is 2:5. So AD is 2:5. So really this is taking up 2/7 of the line, and this is taking up 5/7 of the line. So if we translate that information here, so if we call X the full side from A to B, he's taking up 2/7 X, and he's taking up 5/7 of X. Then we know that this side is 8, and this side obviously is 8 as well. Using similar triangles, find AB, the length of AB. So ultimately we want to find X, don't we? The full length of the side. So how do we use similar triangles to do this? So what I'm going to do is pick a side from the one on the left. So for example, 8. Now 8 is across the way from the blue. So what's across the way from the blue on the other one? The 5/7 X. We're going to let that equals 2. So this time, for example, we can, so whatever triangle we start with, we stick with. So if we look across the way from the pink this time, we have 2/7 X. Across from the pink in the other one is 8. Now, we might just well, actually, no, it's okay. We can just go straight into cross multiplying. So 64 is equal to 2/7 x multiplied by 5/7 x. So 64 is equal to, so that's going to be x squared. And when we do the numbers, that is what? That's 10 over 49. So I think we'll move that first. So we're going to do 64 divided by 10 over 49. Looks a bit messy, but again, we're going to use our calculator here, so it doesn't really matter. 64 divided by 10 over 49. So that gives me 313.6 is equal to x squared. And then we get the square root of that. So getting the square root of 313.6, we get 17.7. It says to 1 decimal place. So the full length from A to B is 17.7.